Hello everyone, you are welcome to the lesson of gradient. We are discussing gradient of a function f. So this is a del operator, also known as nabla, given by I cap del x plus j cap del y plus k cap del z. I cap, j cap and k cap, these are unit vectors along the x-axis, y-axis and z-axis respectively. Gradient of function f denoted by nabla or del f given by partial differentiation of function f with respect to x into I cap plus fy j cap plus fz k cap. So gradient of f gives the maximum rate of change of function f, and this change is given by mod of gradient of f. These are some properties of gradient of f. If function is constant scalar point, then del f equals to 0 vector. If f1, f2 are two scalar point functions, then del f1 plus minus f2 is del f1 plus minus del f2. Del c1 f1 plus c2 f2 equals to c1 del f1 plus c2 del f2. The c1 c2 are constants. Del f1 f2 equals to f1 del f2 plus f2 del f1, and for fractional of f1 f2 it is given by this relation where f2 is not equals to 0. Now we have some questions. This is example, and based on this formula we have some practice question. Find the gradient f for the function 3x square y minus y cube z square at the point 1 minus 2 minus 1. So this is the function of more than one variable. This is function of x, y and z variables. Gradient of f is del f, and del I cap del x plus j cap del y plus k cap del z dot with function f. So we have respectively I cap del x, y and z. Because this is function of three variables, so we differentiate this function partially with respect to, suppose, x here, then treating other variables as constant. Similarly here, if we differentiate this function with respect to z, then we treat remaining variables x and y as constant. After differentiating partially, we obtain 6xy I cap plus this one j cap plus this one k cap. Also we have to find the gradient of function f at point 1 minus 2 minus 1 on putting the value of x equals to 1, y equals to minus 2 and z equals to minus 1. Here So 6 into 1 into minus 2, that is minus 12. Similarly this one. This is the result. This is the gradient of function f at the point 1 minus 2 minus 1. These are some practice questions one can solve easily. What is the greatest rate of increase of function u equals to xyz square at point 103? So this will be 9 answer. And we have next practice question. Find the unit vector normal to the surface x square y plus 2xyz equals to 4 at the point 2 minus 2 3. For this question, unit normal vector, we have to obtain unit normal vector, and you can apply the formula here. Gradient of f upon absolute value of gradient of f. So after solving this one, or we can say this is del f upon del f. This is the unit normal vector, and after simplification one can obtain this is the answer. If you are facing some difficulty or difficulties understanding or solving some problems, you may contact, or you may discuss, or you may comment. Thanks for watching.